Do you know all these three characterization techniques used for a similar purpose? In all these techniques, we basically get X-ray from the sample, and these X-ray contains a lot of information about the samples. So all these three techniques used for elemental analysis. Now, what is elemental analysis? So elemental analysis are basically two types. One is called qualitative analysis, another is called quantitative. Qualitative mean, let's suppose this is our sample and we want to know which element is present. For example, there may be gold, there may be copper. So this is qualitative analysis. Now, if you want to know what is the contribution or what is the concentration of gold or copper in percent form, so that is basically called quantitative analysis. I will also compare the characteristics of all these three techniques in this table here. As I mentioned that all these three techniques used for the similar purpose for elemental analysis. The first one is basically X-ray fluorescence. Fluorescence simply means emission of photon. So in this case, we have emission of X-ray. This is why it is called X-ray fluorescence. In XRF, we simply bombard X-ray on the sample and we get secondary X-ray. Now this X-ray contains a lot of information about the sample, and the graph we basically get, it is like here. On x-axis we have X-ray energy in kilo electron volt. This is emitted X-ray basically, and here on y-axis we have intensity, and we get graph like this with different peaks here. So the peak position here on x-axis, it shows about the element presence, which element is present, and the y-axis basically shows the contribution of that element. For example, if gold is here, this peak belongs to gold, so this peak basically shows the contribution of gold. So here, if the peak basically mean area under the curve, so this area is basically intensity. So large area mean more intensity, mean more concentration or more contribution. Now let's discuss the second analysis. This is called energy dispersive X-ray. This technique also called EDX. And this technique is basically performed along with scanning electron microscopy analysis. So in this case, we simply bombard electrons on the sample because we know electrons also behave like waves. So here we use high energetic electrons, and here these electrons basically eject the core shell electron, and when there is a jump from higher shell to the core shell, there is emission of X-ray. Now this X-ray basically contains the same information just like the XRF. Now let's discuss the third one, particle induced X-ray emission. Here again we get X-ray, and this X-ray we get because of some particle bombardment. So here basically we bombard protons. Protons are basically positive charges. So here we use positive charge particle. We can also use alpha particle because alpha particles are basically positive charge particle. We can also use some ions, but mostly these machines basically use protons is a bombardment particle, and proton do the same job. Basically these protons eject the core electron, and because of that core electron vacancy, we have transition from higher shell electron, and because of that difference in energy, we get basically X-ray here, and these X-ray contain the same information just like the EDX and XRF. Now what is basically the difference is why we use one technique, why don't we use another techniques? Now let's compare their characteristics. So the first one is basically XRF. It is used for bulk analysis. For bulk sample, we know one we have thin sample, thin, and another we have bulk sample. Bulk mean volumetric, and it can be performed in air, very nice, as well as in vacuum when there is no air. Now, the source of excitation is basically X-ray, as we have seen, and we detect X-ray. Now, these X-ray basically contain information about the sample. The detection limit is basically it detects elements, or it analyzes elements greater than potassium in the periodic table. Now, let's discuss the EDX here. It is also bulk analysis. This means that we use this technique for bulk sample here. and it only perform in vacuum here. Very important, because we know electrons are very sensitive, are very light particles. So this is why it only perform in vacuum here. Here the source of excitation is basically electrons, high energetic electrons, and basically we detect X-ray. So these X-ray basically contains a lot of information. Now the elements detection limit is basically boron. Higher atomic number elements than boron we can detect, we can analyze by using this technique. Now the last technique is basically particle induced X-ray emission. It is again bulk analysis, and it is performed in air and vacuum, because here we use protons, heavy particles, so that not affected by the air. Here the source of excitation we know charged particle, but most importantly here positive charge particle here we use. And again we detect X-ray, and these X-ray contain similar information just like XRF and EDX here. Now the element detection is basically higher than sodium here, but importantly I will make separate video on this technique, but this technique is basically multi-element detection. So this is such a powerful technique than the other two techniques. If you find this video helpful, please share, subscribe and like.